getting listing of prime numbers up to a certain point n limit of n with linear time. So its basic idea comes from Aristotle's sieving technique that's in any primary number theory book. To give a number x, basically you try to get all the primes up to x, and then output the number of primes there. The key idea of achieving this in linear time is here in this subroutine, get primes in x up to x. So this outer loop loops from 2 up to x, I less than or equal to x, I plus plus. So st is a flag, basically marking whether it's a prime or not. So if it's not already flagged as a prime, this number is actually a prime number. I is a prime number. So it's put into this prime array. And count will increase by 1. And then, so another loop within this outer loop for I is loops through all the prime numbers found so far. For j equals 0, then prime j times I. As long as prime j times I is less than or equal to x, then increase j. And set all the flags to be true, so to mark they are actually composite numbers. So you want to see them out, take them out. Prime j times I is basically a composite number. You mark them as a composite number to take them out. And one additional step here is to check if actually the current prime number divides I without any remainder. So I mod prime j, if it's 0, then you just break out of this inner loop and continue the outer loop for the next I. So this way it guarantees basically you are using the smallest prime factor to sieve out the composite numbers once and only once. No repetition, no double counting, and no undercounting, no overcounting, no undercounting. So this loop here, inner loop, achieves that by looping through all the prime numbers found so far and take out their multiples times I and set them to be composite number and set them to be flagged. And if you are actually dealing with another prime number, if I mod prime equals 0, basically this prime number is already a factor of I. So prime j is the smallest prime factor. You will break and continue to the next I. If it's not, it will just continue through this within the inner loop and looping through all the prime numbers found so far and use those multiples times I and mark them as composite number. This way it guarantees basically you are using, the key idea is to use the smallest prime factor of any number to sieve it out once and only once. So this code achieves that.